Okay, so in this video, I'm going to explain the solutions to the items that came out during the pre-assessment. So we'll start with question number 1. So in question number 1, we have two items, A and B. So the first one is about the difference of 8 over 3 plus 2 square root of 5 and 4 over 2 square root of 5 minus 3. So I skipped some steps, but you should end getting this. So the idea is you have to get the LCD, and for expression like this, the LCD will be the product of these two. So as you can see, you have 3 plus 2 square root of 5, and you also have 2 square root of 5 minus 3. Now, this is how you understand how this was obtained. So you're trying to, when you try to add fractions, you need to get the same denominators. So you can think of it like if you want to produce 3 plus 2 square root of 5 and 2 square root of 5 minus 3, then you should multiply this by 2 square root of 5 minus 3. So you do that here, and then you also do that in the numerator, square root of 5 minus 3. So that is why you see the 8 being multiplied to 2 square root of 5 minus 3. That's how this was obtained. Some people would say just cross multiply, although that's not mathematically correct. Okay, but what is actually happening here is you're trying to make the denominator like this. So to get that, you have to multiply the numerator by 2 square root of 5 minus 3, and also the denominator by 2 square root of 5 minus 3. Now with the same idea, to get 4 times 3 plus 2 square root of 5, in the second fraction you only have this denominator. So you want to have a 3 plus 2 square root of 5. So when you have 3 plus 2 square root of 5 here, to neutralize that, you should also have 3 plus 2 square root of 5. That is why you see a 4 being multiplied to 3 plus 2 square root of 5. So that's a long way of getting it. So some people make it easy to remember, like the denominator will be the product of these two. Okay, so as you can see here, and then you get to cross multiply 8 and 2 square root of 5 minus 3 and 3 plus 2 square root of 5 times 4. So again, that's not mathematically correct, okay, because there's no such thing as cross multiplication when you combine. So it's just a way of some people to easily combine fraction. Okay, so it's just a technique. Okay, it's a technique created to easily remember some process. Okay, so once you do that, so you will now distribute or simplify the numerator, and you should be able to get this. Okay, so getting this relies on your ability to multiply radicals properly. So just some notes: when you multiply radicals, you can only multiply numbers to numbers and then radicals to radicals. So meaning, if you look at this 8 here, so this is the 8, gets to multiply to 2 but not to 5. That is why we get 16 square root of 5. And then we distribute 8 to 3, so you get 24. So from the second group, we have 4 times 3, but there's a minus sign before it. So 4 times 3 is minus 12. Then 4 times 2 square root of 5 will be 8, or minus 8 square root of 5. Then try to combine radicals. So you have 16 square root of 5 and minus 8 square root of 5. So basically 16 minus 8 is 8 square root of 5. Okay, and then negative 24 or minus 24 minus 12 together, that will be minus 36. Below you have 6 square root of 5 and the opposite, so minus 6 square root of 5. So that means this is 0. This will become 0. So you have minus 9 plus 4 times 5, which is 20. So you have minus 9 plus 20. Minus 9 plus 20 is 11, so you get this 11. And then you have 8 square root of 5 minus 36 still as the numerator. So from here, you're not expected to simplify this anymore. No need to like change it into two fractions, so just have it as a single fraction. Okay, so let's look at the second one. So the second item, so you see a group here multiplied to 2 is equal to 3. So I made a note that this can be done in many ways. So it means the first step could vary depending on how you attack the problem. So some people will try to combine this immediately. So some people will distribute 2 is equal to 3 first to each term. Okay, and that's exactly what I did here. Okay, so as you can see, the 2 is over the square root of 3. When you multiply it to 4 over the square root of 12, so I'll get 2 times 4 is 8. Square root of 3 times square root of 12 is equal to the square root of 36. Okay, so 3 is inside the square root, 12 is inside the square root, so you can multiply 3 and 12 to get 36. But make sure that the resulting number is inside the square root, because 3 and 12 are inside the square root. And then you do the same thing. So 2, as you can see, 2 is not multiplied to 27. 27 is inside the square root, so you have 2 outside, and then you have the square root of 27. Then square root of 3 times 3, so that's basically 3 square root of 3. Again, you don't make it square root of 9 because 3 is a whole number. Square root of 3 is a radical expression or radical number. Okay, so then we continue by simplifying this. We know how to get the square root of 36. And basically that's 6, 2. Okay, so there's a rule. When you have square root over square root, you can have them as a single square root, but they will stay as a fraction. So as you can see, so this is 27 over 3. So they are now inside a single square root. So that's a property of surds or radicals. So 27 over 3. So when you continue, so you have 8 over 6, then you have 2 over 3, and 27 over 3 is 9, so you get the square root of 9. Okay, you simplify. 8 over 6 can be reduced by 2, so 8 becomes 4, and 6 becomes 3. Square root of 9 is 3, so that is why you see a 3 here. Now to further simplify, 3 and 3 will cancel, so that's why you have a 2, then 4 over 3. So just add this 2, and you should end with 3 plus 3 and 1 over 3. Okay, so that's how you do number 1. For number 2, so this is about solving exponential equations. So the main idea in solving exponential equations is that you have to convert all the base into the same base. And in this case, you see the base 3, 9, 27. So all these numbers can be changed into base 3. So what we did here, so we changed 9 into 3 squared. So you see the 9 being changed to 3 squared, and then 27 is being changed to 3 cubed. And then after that, you just have to apply properties of exponents. So 3 to the x stays as 3 to the x, but 3 squared to the x minus 2. So this is a case of a power and a power. So when you have a power and a power, you have to multiply the exponents. So you have 2 times x is 2x, and then 2 times 2 is 4, so with a minus sign. On the other side, so we apply the same idea. So 3 times 3 is 9, and then 3 times x is 3x, and then with a minus sign. And then you continue, okay, by having these two combined. So this is a quotient of 3 to the x over 3 to the 2x minus 4. So remember, when you make a quotient a single base, you have to subtract the exponent. So I want you to take note how I place the parentheses so that I cannot be, or I could avoid error in signs. Okay, so x, that's my exponent of the 3 on the numerator, and then you have 2x minus 4 as the exponent of 3 in the denominator. So quotient means you have to subtract the exponent. So on the other side, so just copy, because there is nothing that we can do about 3 to the 9 minus 3x now. So x minus 2x minus 4 means x minus 2x plus 4. So this will be reduced into negative x. 4 will stay as 4. And then we have the same 3 to the 9 minus 3x on the other side. And then this is how you attack it now. So you see these two are the same. So if this is 3 and 3 and these two expressions are the same, then that would mean the exponents are also the same. That is how we got this equation. This is through the exponents. So negative x plus 4 is equal to 9 minus 3x. So from here, all you have to do is to solve this equation, and you should be able to get 5 over 2. Okay, so moving on. So we have another equation here. So you have 3 to the 100x minus 4 times 10 to the x equals 4. So this is a case in which you have to change it into 10 to the x. Okay, so I could see a clue here. This is 100x, and 100x can be expressed as 10 to the x, which we could see here. So I know that 100 is 10 squared, so I change it into 10 squared. Okay, and then I copied the other expressions. And then from here, so note I need to create a 10 to the x. So I will swap the exponents, which is allowed, because these two are the same. So even if x is here and 2 is outside, it's basically the same as 100x. Okay, so I did that because I need to create a 10 to the x. So once I have this, I can assign a letter to 10 to the x, and that will make the equation of the form 3y squared minus 4y equals 4. And if you look at it, this is a quadratic equation. So all we have to do is to solve this quadratic equation. So we have 3y squared minus 4y equals 4. So I have to make the other side equal to 0. So you will now create this. Okay, and then the next step would be to factor the expression. So in this case, it's factorable. So we have 3y plus 2 and y minus 2. And then each factor being equated to 0, which will give us y equals negative 2 over 3 and y equals 2. Now take note that we are not looking for the value of y. So we're not looking for the value of y, but we're looking for the value of x. So since y has two values, negative 2/3 and 2, so the 10 to the x could take these two values. So you could see here two equations. Okay, so one for this y and the other for this y. Okay, so this can be a bit tricky. So always take note that when you work with exponential expression, if it is in this form, like you're looking for an x that you use on 10, so the exponent on 10, that will give you a negative 2/3, that cannot happen. Okay, because when you raise 10 to any exponent, the value is always positive. So it will never happen that this 10 to the x will be equal to negative 2 over 3. So that is something that, can be analyzed. Okay, so there's a conceptual understanding, okay, when it comes to 10 to the x. Okay, now as opposed to 2 equals 10 to the x, this can be solved by expressing this into logarithmic form, because that's the only way that you could bring down the exponent x. So when you change this to logarithmic form, you should be able to get x log 2. Okay, so log, the base is 10, we don't see it here, and that means it's base 10. Okay, so if you want to check, if you change this back into exponential, you should be able to get this. Now this is already x, and we're looking for the x, and x is equal to log 2. Okay, so let's move on. So we have here 2c. This is about solving log and exponential equations together. Okay, so basically what we did here is that we changed the log equation into an exponential equation, which gave us this 9 equals x plus y. At the same time, we simplified 3 to the x divided by 9 to the y equals 1 over 27. So into this form, so using the ideas that we learned from the previous item, we should be writing this into the same base, and that will be in base 3. And then just simply apply properties of exponents and you should be able to get this equation, okay, which will give us x minus 2y equals negative 3. So this came from, since again take note these two are the same, so when the bases are the same, then it should imply that the exponents are the same. So this is why we have x minus 2y equals negative 3. So from there, you have these two equations. So all you have to do is to solve the x and y from here. So you can use different methods like elimination, substitution, you can even use graphing. Okay, but that's your last option, supposedly. And then use elimination, and then you will be able to get y, and then once you get the y, you should be able to get the x. I won't be explaining that because it's a skill that you should have learned before this topic. Okay, so if you want to review your solving equations, okay, that should be done in a different time. Okay, so but just to give you an idea, after getting these two equations, all you have to do is to solve this system of equations, and it should give you the values of x and y. And in this case, it's x equals 5 and y equals 4. Okay, moving on. So let's look at logarithmic equations. Okay, this is number 3. Okay, so the problem was we want to solve this equation. So what I did here is I subtracted log 5 3k minus 1 on both sides, so I get this now. And then the difference of the two logs can be written this way. That's a property of logarithms. When you have the difference of logs, you can write it as a single log, and then you express 3k plus 1 and 3k minus 1 as a quotient. Okay, so you see a fraction here. Now we were able to do that because of the bases, or because the bases are the same and they're both 5. Okay, so from here, so once you have a single log equals to a number, one way that you can do is to change it to exponential. So you get the base 5, so this will have the exponent 2, then equals to 3k plus 1 over 3k minus 1, and 5 squared will become 25, which will give us this equation, something that you can solve algebraically. Okay, so I will not be giving you the detailed explanation on how I did this. Okay, but apply algebra. Okay, and then you should be able to get k equals 13 over 36. Okay, so you can just look at the solutions and work on it on your own. Okay, and then 3b. Okay, so this is a bit different to the previous one. So you see a lot of letters. You have b, you have e, and you have log and ln. So ln simply means natural logarithm, and for natural logarithm it means the base is e. Okay, so this ln simply means log e. Okay, that's why when you look at the first step of the solution, you should see how ln p was changed into log ep, because ln means log e. Okay, so we have 2 log p, or e base p equals 5. Now we cannot combine these two immediately because this is base e and this is base p. So by the rule, logs can only be combined if they have the same bases, which is not the case here. But there is a way to make the bases the same. There is a change of base formula that could give this expression which is equivalent to this. So look at how the base was transformed to e. So it's like you're interchanging p and e. Okay, but note how this became a fraction. Okay, so just some note, log pe is the same as 1 over log, so when you interchange e and p. Okay, but since there is a 2 here, so you have 2 over log ep, then equals 5. So from there, you solve this equation by multiplying log EP both sides, okay? So we're trying to avoid denominators here so that we can easily solve the equation. So when you do that, you should be able to get this, okay? So that's 3 log EP times log EP. You get the square of log EP. And then there's no more log EP on the second. This is why you only have the 2, but the 5 gets a log EP, okay? And then subtract both sides by 5 log EP. So this will become 0, and then you have a new 5 log EP on the other side. So note I already arranged it because I am expecting a quadratic equation here. How did I know that? Because I see a square. Okay, so this is a similar strategy that we did in the previous item. So we set a value for this. So let's say y, okay, which will make it 3y squared minus 5y minus 2 equals to 0, which is exactly this. Then from here, so you factor the quadratic equation and you get these two factors, 3y plus 1 and y minus 2. Equating these factors to 0, you get the first y to be negative 1 over 3 and y equal to 2. Okay, note y is not what we want. It's the value of log EP. So observe how I change y into log EP. So you have log EP equals 1/3 and log EP equals to 2. Okay, to get the value of p, simply change it to exponential. So the first one is e raised to negative 1 over 3, and the second one is e raised to, so this is e raised to 2 equals p. So I have two values of p, and that's e to the negative 1 over 3 and p equals e squared. So are there any restrictions here? E squared is always positive, e to the negative 1 over 3 is always positive, so these two solutions are accepted. Okay, let's continue. Finally, you have this problem in which you have to simplify a lot of logarithmic expressions. Okay, but this problem simply relies on your ability to change the base. Okay, so from here, so let's look at the steps. So from here, I want you to observe how this was transformed into log 8 over log 5, so which is what we see here. This is log 25 over log 2 by the change of base. And then you have 2 log 3 and then log 9 again by the change of base. We do the same, although we did some initial steps. I see a cube root which can be changed to raised to 1 over 3. At the same time, square root is raised to 1 over 2. And then continue simplifying. Let's look at how the numerator was simplified. 8 became 2 cubed. Okay. 25 became 5 squared. And then 9 became 3 squared. So 1/3 by the power law, you get to write to 1/3 here. So you have 1/3 here and then log 5/5. Then 1/2 power law, you get 10 times 1/2 and then log 4/2. And then we continue. So it's a bit long, but it should not be difficult. Okay, so you have the exponent 3, because you will notice you get a 6 here. So that's when you put the 3 here, the 2 gets multiplied with 3, so you get a 6. So you have log 2 and then log 5. The 2 from here will be moved here. So you have 2 log 5 and log 2. And then on this one, so you see how the 2 was transferred here. So you have 2 log 3. So from there, you just cancel the common values within a group. Okay, so don't cancel like log here and log here because there's a minus sign. So this is a group. You could cancel log 5 and log 5 here, log 2 and log 2. On the other fraction, 2 and 2, that's 1. Log 3, that's 1. Okay, in the denominator, log 5/5, that's a special property. When the base is equal to this, it becomes 1. So 1/3 is multiplied to 1. Then 10 times 1/2 is 5. Log 4 2 became log 2 log 4. Okay, so we're almost done. Okay, so take note what's left in the numerator. You have 6 and 2. So that's 6 times 2. And then this becomes 1, so you have minus 1. And then 1/3 times 1 is 1/3. Log 2 log 4. 4 is 2 squared, so we change it. And then we have 6 times 2 is 12. Minus 1 is 11. This 2 can be written here. After doing that, log 2 and log 2 will cancel, and you have 5/2. So in the end, you should have this fraction, and simplify this fraction, you get this, and then finally simplifying that should give you 66/17, or 3 and 15/17. Okay, so that's how we solve the items in the test. Okay, so we had 4 different skills. Okay, so one with the surds, the second with exponential equations, the third with logarithmic equations, and finally some extended idea on logarithms, and that is by using the change of base formula. Okay, so let me just show you each item again. So this is number 1. Okay, so you can pause the video if you want to see the solution quickly. Okay, and this is the solution for 1b. Okay, this is for number 2, and then we have until here. Okay, for number 2b, so we have this. Okay, so take a look at it. Okay, you can pause the video if you want to look at the solution. Okay, one by one. Okay, and then the next, so you have 2c. So that's a problem given here. Okay, it's given here, and then apply steps, and you should be able to get x equals 5 and y equals 4. And then the second log equation. Okay, so that's the second log equation. And then finally we still have 3b, so another log equation. Okay, so these are the steps. Okay, until you get these values. Okay, then you have this. Okay, the change of base formula problem. Okay, so this was the given problem. Okay, so we have a series of steps. Okay, a series of steps until we have the final answer, 66/17. Okay, so I hope you were able to understand my explanation here. You may find it a bit fast because I'm trying to cover everything here, but hopefully by studying my solutions here, it will be able to help you to solve the problems next time. Okay, so I think that would be it. Okay, so you can always go back to this video if you need to review the items. Okay, so that's all for now. Okay, so bye bye.